Lesson 2, sine law with obtuse triangles. So when you have an obtuse angle in a triangle, that means you have an obtuse triangle. And remember that obtuse means that anything greater than 90 degrees. So because we found that the sine law is equal for acute angles and obtuse angles, it can be a little bit difficult to find that obtuse angle. So we're going to do example 1 first. So in triangle ABC, so let's draw it ABC. Draw a quick sketch. So side A is 65 degrees. 65 centimeters. Side B is 40 centimeters. And angle B is 23 degrees. So while we're doing our sine law, we are going to look for sine of A. Now there's two possible options here. It could either be an acute angle or an obtuse angle. So we set up our ratios. So the sine of A over 65 equals the sine of 23 over 40. Now we're going to solve for A. So we're going to multiply both sides by 65. And we're going to find the angle, so we're going to do sine to the negative 1 of 65 sine 23 divided by 40. So type that into your calculator. And you should get 39 degrees. So that's one option. To find the obtuse angle, you could also do angle A is equal to 180 minus 39. And you should get 141. So the acute angle of this triangle would be 39 degrees, and the obtuse triangle would be 141. Example 2. A weather balloon is tethered to the ground. So let's draw the ground. And a weather balloon. And it's tethered to the ground. You observe the balloon above the ground at an inclination of 7 degrees, 250 meters away. So you're 250 meters away, and you're observing the balloon 7 degrees. Your friend is standing where the balloon is tethered and observes the angle of elevation to be 82 degrees. So if you look, this is above the ground. Your friend is standing here, and he's looking up, and this is 82 degrees. Find the height of the balloon above the ground. So we want to find how high it is above the ground. So we have two triangles. And first of all, we're going to find this angle so that we can use the angles formed in our first triangle to solve for this length. So this angle will be 180 minus 82, which is 98 degrees. A popular band from the 90s. Now, we have this triangle. And this is 7, this is 98, and this is 250. And we want to find this side because it's the first angle, or the first side that corresponds with the other triangle. So we're going to find our remaining angle. So we take 180 minus 7 minus 98, and you get 75. So this angle is 75. So now we have enough information that we can use the sine law to find side y. So we have y over the sine of 7 is equal to 250 over the sine of 75. Multiply both sides by sine 7, and you get y is equal to 250 sine 7 divided by sine 75. Type that all into your calculator, and you should get 31.5 meters. So this side is 31.5. So now let's look at this triangle. We know that this is a right angle because it's made going straight up into the air and the ground at 90 degrees. This side is 31.5 and this angle is 82 degrees. Now we're looking for x, and we're going to just use the primary trigonometric ratios. So remember that those are SO, CA, TOA. From our angle, we know the opposite side, and we know the hypotenuse. So because we have an O and an H, we are going to use the sine law. So sine of our angle is equal to opposite over hypotenuse. So sine of 82 is equal to x over 31.5. Since x is on the top, you multiply. So type 31.5 sine of 82 is equal to x. And you should get 31.2 meters is equal to x. So the height of the balloon is 31.2 meters above the air. And by that I meant ground.